GSM industry has been making it very hard to do security analysis, legitimate and non-legitimate. There are well-known security problems in the GSM stacks, both in the implementation as well as in the specification itself. Now we have multiple solutions for sending arbitrary protocol data, both from the network as well as from the telephone. There's OpenBSC, OpenBTS for the network side. There's OsmocomBB from the baseband side of the telephone. We also have injection proxies, so if you get at one of the other interfaces in the network, in the core network, then you can also inject messages from there. So that's really all there now. Where to go from here? Yeah, as I said, we're still waiting for somebody to do the fuzzing integration. It's up to the security community to make use of this, and I personally think TCP/IP security has been boring for a number of years. There's RFID, there's Tetra, there's GSM, there's 3G, there's DECT. You know, there are all these communication systems out there. You know, why did nobody ever present here about a GPS transmitter that sends arbitrary satellite information and confuses GPS receivers and so on? There's so many communication systems out there that are waiting for somebody to do practical security analysis. You know, don't look at TCP/IP all the time. It's boring. It's old. Okay, some thanks, because this really is a group project. We have Dieter Spar, who has been very invaluable to the project. Unfortunately, he was not able to make it to the presentation due to a lot of snow, and he lives in a very remote location. We have Andreas Eversberg, who has been spending most of his summer to implement the layer 3 and the cell reselection and all this. Sylvain Mounon, who has already been on stage yesterday, doing a lot of layer 1 and DSP work. And we have other developers who are working on open source GSM stuff, just to name a few. I really want to thank these guys. They boldly go where no man has gone before. Some links if you want to read more about all this, and now we have 14 minutes for questions. Please raise your hand and you know, go to a microphone and so on. Don't just scream or shout into the hall. Questions?
As for the questions, I want to say that please go to the microphone stands on the left and the right side.
Hey, go to the microphone stands, not outside the door. Thank you.
Yes, there's a question right there.
You mentioned that OpenMoco has the same chip, so since it already has a USB port, how feasible it is to run those tests on it? Have you tried it?
The USB port of any smartphone, including the OpenMoco smartphones, is connected to the application processor, which is a different processor on the same device. So if you want to run OsmocomBB on the OpenMoco telephone, what you do is you run the layer 2, layer 23, all the applications. You run it on the application processor of the telephone itself, and you run the layer 1 and the firmware that we do for the baseband processor in the processor. So with the OpenMoco phone, you don't need a PC and the phone, but you can run everything inside the phone. But without an external PC, how do you type in the commands to the telnet command line? So you will still somehow need to access it externally.
I have some questions. Hello.
I
have some questions from other missions. One question from Wutang in England is, would it be possible to create a peer-to-peer GSM network with this modified baseband?
Not really. The fundamental problem that you face is that the uplink and downlink frequencies, which is the frequency from the cell to the phone and from the phone to the cell, they are, depending on the band, between 45 and 90 megahertz apart in frequency. There are hardware filters in the receive and transmit path of the telephone that limit the frequencies you can receive or transmit on. If you do those hardware modifications, so if you do hardware modifications to exchange or replace those filters, then you can turn one telephone permanently into the other way. So it could behave like a cell, but then it could no longer behave like a phone. And aside all of that, you have problems with the timing, because the timing is there's always a clock master. It's a synchronous system. all the telephones are slaves of the clock master, the BTS. So you can probably get a prototype working of 2 telephones or 3 telephones talking to each other, but it's never going to scale and it's never going to work, and especially not without hardware modifications. So I think it's a bad technology for doing that.
Hi. Hypothetically, does the baseband software have to identify itself to the operator? So hypothetically, if you were to talk to a real network, would you have to lie and pretend you were one of the 4 official baseband software or some derivative?
No, there's no inquiry, neither authenticated or non-authenticated, onto what particular implementation it is running. There's nothing like that. You indicate the features that you support, like do you support this codec or this cipher, or do you do this, or which band do you support, what's your transmit power, and so on, but it's always on feature base and never on vendor base.
Are operators likely to get annoyed if you were to, or are there any legal implications if you were to hypothetically run this against a real network?
Well, if you hypothetically run it, I think there's no legal implications, but if you really... Sorry. But if you practically run it on a real-world network, which works very well, by the way, I don't really think there are legal... okay, so you might violate the terms of services of the operator, and if the transmitter, in case the transmitter would not behave according to the regulatory things, regulatory requirements, then you may have some issues there. But even then, unless you actually disrupt communications in a public telephone network, that's sort of, at least according to German law, if you disrupt or interfere with a public communications network, that's subject to up to 5 years of imprisonment. So that's really serious. But just, if it transmits a little bit strangely without causing interference, that's a minor offense, not a big deal. Yes, you might violate the terms of services and the operator may terminate the contract or something, but it's not really a serious issue, at least based on my knowledge about the legal situation here in Germany.
You said about the timing advance, that you can change the timing advance as you like to fake your position. But I remember a lecture from my professors in electric engineering that it's the problem, because if you move it too long, then you will destroy the timing, because you have a distance to the base station, and so the timing advance is to compensate for this distance. And if you move it too long, then you will destroy all the other packets of the other people who have a different distance to the station.
No. The point is not that you transmit. So what we do with the timing advance is that the network tells us, based on your current receive delay, please switch to timing advance 2. But we don't switch to 2, maybe we switch to 3. But we tell the network we switch to 2. So on the air interface, everything is like it's supposed to be, everything is in the time slot it's supposed to be. Just because the network told us something different than we did, there is a wrong assumption of where we are. But there's nothing, no interference or anything wrong on the air interface.
What would happen if, for example, you're standing next to the base station and put the maximum value of timing advance?
Well, the point is that we never put the maximum value. We just claim to the network that we are.
Okay, you claim it, okay, but you don't do it, because otherwise you would destroy the packets.
Yeah.
Okay, so what about doing man-in-the-middle attacks? Because you could, for example, take the phone into a base station and take a next phone to be a phone, and then you can, for example, do man-in-the-middle attacks.
That's only possible if you know the problem is there's still the authentication and encryption at that point. And even if you break, you need to break the encryption key fast enough in such a setup. I'm not sure how feasible it is right now, but it's definitely not as easy as some people may think to do the full man in the middle that actually behaves like a proxy. By the way, Rode and Schwarz, a German company of an infamous name, has a patent on this. It's called the virtual BTS, the VBTS, and there's a European patent on the man-in-the-middle attack in GSM networks.
Another question here from somewhere else in the planet. Can one create a GSM server?
There is no terminology in GSM like this. Sorry. I mean, a GSM base station, some people are... a telephone doesn't have the processing capacity that would allow it to run a full base station. Sylvain is doing some work on sort of doing a poor man solution that would allow you to make two phones talk to each other, but it's the processing power of the DSP is not meant to fulfill the requirements of a base station, because a telephone only always transmits and receives on one time slot, because it has one conversation. You don't have 2 or 3 or 4 parallel conversations on a single GSM phone, so you use one time slot. But the base station always needs to provide 8 time slots at least. For all the other telephones and so on. And the CPU, the DSP is just not capable of processing 8 different time slots all the time. So there's some restrictions. Okay.
When I use the OsmocomBB on a commercial provider network, should I be afraid of disturbing the provider's network in somehow, or is it that stable already so that I'm not afraid to crash the operator's network?
I will not recommend you to do that, no. I mean, it is an experimental project. It's meant for experimentation. We are using this mostly against our own networks. We are also using it, I mean, it also depends on what you do. If you just want to do logging, if you just passively read the system information from the cells, then there's no way you can cause interference. By the way, the default compile configuration of our software disables transmit. So unless you manually edit the makefile and put in some statement that will enable the code for transmit side, it will be receive only, and in that case you cannot cause any interference. So this is a way how you can start to play with. The other thing is, there are operators that are actually interested in testing their networks, and there are some where we've been into the operator lab and be able to use our software against their lab setup. I mean, yes, you can use it in a commercial network, but there's no type approval, there's no no legal guarantee, and there's no technical guarantee. I'm fairly confident in the software, but things can always go wrong.
Another question here. How big is the effort to port to other basebands, like GNU Radio or USRP?
That's a completely different architecture than our architecture. The GNU Radio and USRP are software-defined radios where all the signal processing happens in software, whereas the typical GSM design is a much more traditional receiver design. And we are also using for the actual modulation and the modulation is done in hardware. In our case, there's hardware inside the analog baseband that does this. And the demodulation of the signal is done inside the DSP, which has mask ROM code. So the entire receiver architecture is very different. And if you were to, so somebody actually did this. It's not open source, but somebody has taken the OpenBTS code and changed it to no longer be the clock master, the BTS, but to implement the telephone side interface and then put the protocol stack on top of this. You can do it, but you have to know what you're doing. I mean, you need the actual receiver, the signal processing part, in addition to our stack in order to run it on a software-defined radio. And for the signal processing of the telephone side, there's no open source code for that. Also, the USRP costs thousands. Well, it's a 4-digit amount of money. The telephones we use, they cost what, 15 euro, 20 euro. So I would strongly recommend using the telephone. And it has much more output power, right? It can transmit at 2 watts. The USRP only has a couple of 100 milliwatts.
You mentioned you are also able to emulate a SIM card. So if you were to able by accident the SIM card of another subscriber from a mobile and make a call, would the other provider, the other person's SIM card get billed?
The problem with this is that you don't have the encryption key and the authentication key of the other SIM card normally, okay. Right? So we can emulate it if you have the key, but you know, since normally you don't have the key, you will not get